Good morning, all of you. So today I am here to present the lecture on software engineering. The subject is software engineering, and the topics that will be covered today are evolution, evolution of the software, SDLC, that is software development life cycle, and agile software development. So the three topics that will be covered today are: first is the evolution of the software engineering. How the software engineering world evolved. What are the reasons where we require the software engineering? What is the need of the software engineering? So this is the first part of today's lecture where I will discuss the evolution of the software engineering. The second part is SDLC, that is software development life cycle. So here we will cover what is actually the whole process of developing any software. What are the phases that are required to develop any software? So that is will be done in a software life cycle, and we will also discuss the various software development life cycle models. And the last topic for the today, the last part for the today's topic is the agile software development. So what this word agile means, what is the requirement of this methodology of developing the software. So this all will be covered in today's presentation and today's lecture. For this, I have prepared the slide also. So I will soon share the screen where I will discuss all the topics that I have just told you. So I will just go and share the screen for you. Okay. So this is the my slide presentations on the first part of today's lecture, that is the software evolution. So I will just start with the first slide. So what is the objective of this part, that is the software evolution? After going through this unit and this part of the unit, first unit, you should be able to understand the evolving nature of software development. You will be able to understand how the software development, how the process of developing the software evolved. Basics of the software development. What are the basic things which are required, or the basic issues which are considered in a software development? And what is the engineering behind the software development? That is, what is software engineer we are talking about? So what is engineering behind the software development is basically the software engineering. What are the phases needed to develop the software? And you should also understand the role of planning the software development. So introduction to the software engineering. Just go through these two short paras about the introduction to the software engineering. I will read out for you, then I will make you understand. Software engineering is an engineering branch which is associated with the development of the software product using well-defined scientific principles, methods, and procedures. What does it mean? So this is the engineering, which is a whole process, and it is a scientific process which is based on a scientific principles. It applies the scientific methodologies and the procedures, set procedures to develop any software product. That is software engineering. And when we implement this software engineering principles in developing any software, the outcome of the software is an efficient. So what outcome, what the software which is developed, it will be the efficient software, and it will be the reliable software product. So this is the advantage, or this is the basic of applying the engineering behind the development of any software. So implementing or applying the engineering means you have to follow certain scientific principles. You have to follow certain methodologies, the set methodologies, the standard methodologies, and the procedures. So according to the IEEE, it defines the software engineering as the application of systematic, disciplined, quantifiable approach to the development, operation, and maintenance of the software. That is the application of engineering to the software. So what it says, it is an application of the engineering to develop the software. So it deals with right from the development of the software, all the operations which are there in a software product, and also taking into account the maintenance of the software. So this is actually what is the software engineering. So how it evolution, see the cycle. So the process of developing the software product using the software engineering principle and methods is referred to as software engineering. Means is referred as software evolution. So when we apply the software engineering principles to develop any software a product, the whole process involved is basically the software evolution. We start from nil and we finally reach to the developed software. So this includes initial development of the software and its maintenance, as well as the time to time updates till desired software product is developed, and that software product should satisfy the expected requirement. So you can see the cycle there. See the cycle. I will explain this cycle. It start from the request, impact analysis, planning, then updation is released, then the system is released, and again change. If there is request to change, again then change is incorporated into the software, and this cycle is there. So next. So evolution starts right from the requirement gathering process. What is the basic requirement that the software needs? What is the basic requirement which is needed for the software to be developed? After which developers of the software create a prototype or the throwaway of the intended software and show it to the users to get the feedback at the early stage of the software product development. Still, the software is not launched in the market. It is to the friendly users. Then user uses that prototype. They suggest the changes on which several consecutive updates and maintenance keep on changing too. And if when customer says yes, is satisfied with the all through its feedback, then this software is launched in the market. So this process changes to the original software till the desired software is accomplished. Even after the user has desired the software in hand, but nowadays the technology is advancing and changing day by day. New features are being added. There is a requirement to add the new features to your software to cope up with the changing environment, changing requirement of the users. So product has to change. So similarly, in whole this process, not only development is required, but making the updation and the proper maintenance to the software is also needed. And recreating the software from the scratch and to go one on one with the requirement is not feasible. So therefore, we need to continuously update the already developed software. We need the re-engineering of the software. The only feasible and the economical solution is to update the existing software so that it matches the latest requirements which are put forward by the users. So what is the software paradigms? What are the different, you can say, main processes which are included in a software development, and they are one between the another. So in the diagram you can say the software development angles in it. First of all, the basic thing is design, the design process, design, making the blueprint of the software, then doing the programming. First over the design, the blueprint is designed, then the coding is done. That is through some programming language. So this is the paradigm of the software. So what is the need of software engineering? Why we need the software engineering? What is the reason the need of software engineering was felt? The basic and the foremost reason is we want to make a quality product, and the quality product is only developed if the product is made, if we follow certain principles, and that to the scientific principles. We have to follow the standardized process. We have to follow the standardized methodology. These standardized principles, methodologies, process of developing any software is the what that is provided by the software engineering. That is known as the software engineering. So nowadays, there are the several reasons we see that we need the software engineering. And the one thing is the dynamic nature of the requirements. As and on, if you launch the software, the user requirement keep on changing. It is dynamic in nature. So to incorporate the required changes in a software, it is very easy if we had developed the software following some software engineering principles. So this is the basic need of the software engineering. Second is these are the certain features or the characteristics or the reasons we require the software engineering. First is large software. You see that the size of today the software product is very large. So it is easier to build a wall than to house or building. Likewise, as the size of software is becoming very large nowadays, software products engineering has to step to give it a scientific process. If it would have been very small size software, then it could be handled without applying the engineering principle. But now the size is very large. So we have to develop the large size products through applying some engineering principle. Next is scalability. Time to time, the number of users that are using your software may increase to the certain level. So if we have followed the engineering principle, we can very easily scale up our product. Cost also, if we have made the software through some software engineering principle, then you can see the cost is also less because everything has been done in a proper manner. Just see, as hardware industry has shown its skills and huge manufacturing has, it has also lowered down the price of the computer and the electronic hardware. But the software remains, the cost of software remains high if the proper engineering principles are not followed. So if we follow the proper software engineering, then we can have a control on the cost of the software product. Next point is dynamic nature that I have already discussed with you. And last is quality that I discussed in the very first point, that the main thing which is required, which is desired, or you can say your software will be remain in the market for the longer period if it is a quality product. So if we want to make a quality product software, then it should be developed through software engineering only. So without using software engineering principles, it will be very difficult to develop the large programs. This is large products. And one thing more, that the scalability factor and the size. You see, just see the example. If the size of any product is 1000 lines of code, and but a program with 10,000 LOCs needed, so it is 10 times, but the efforts, the difficulty is not that 10 times. If the size of the software increases, the relation between the effort and time to developing is not in the same multiple, but it is in the form of exponential manner. So therefore, if we do not implement the software engineering principles, then the effort will be very, very high, not at the multiple of the size, but effort will be in the form of exponential order will be required. So in such situations, software engineering techniques come to rescue, and your software should be developed following the software engineering principles. So just see the relation between the size and the complexity, effort, and time taken to develop the software. So it is the exponential. It is not the linear growth. Then very important term is software crisis. Nowadays, there is no crisis in the hardware, but there are the crises in the software product. Why? Why? What are the reasons that there are the software crises? They do not. What are the you can say characteristics which will define that yes, there. What are the factors that will define yes, there is a software crisis? So you can see if your software fail to meet the user requirement, it leads to one of the situation of the software crisis. Your software frequently crashes. If your software is expensive, then there will be no buyer. So it will also result in a crisis. If your software is very difficult to alter or update or make changes, it also results in software crisis. If it is very difficult to debug and enhance the software, then it is also the reason. If your software is late deliverable, this is one of the reason. Use resources non-optimally. If we have developed the software and it is not using all the resources that are allocated to your software, then we see that there is a software crisis. So these are the factors which which result into the software crisis. So just see. So the cost of software and the hardware relation. So it also sometimes leads to the software crisis because the cost of the software becomes very high as for the hardware. So factors responsible for software crisis are larger problems. If because the development of the software products, now there is the requirement of larger software products. So if we do not follow the software engineering principles, it will result into the software crisis. Lack of adequate training in the software engineering, increasing the shortage of skills which are required to develop the software products, and the low productivity improvement. So these are the factors for a software crisis. Next very important thing is what is the difference between a program versus the software product. So now what up till now what I have discussed with you is that's the requirement of the today is as the requirement by the user, we have to develop the software products which are larger in size. Earlier, what happens? The small programs were made, but now the requirement is of development of the software product. So what is the difference between the simple program and the software product? So for a program, first of all, it is being developed by the very single person. Basically, the program is developed by the single person. Single person is involved in making a software program, or one or two persons. On the other hand, the software product needs a team. It needs a team. And the user, there is mostly the sole user of the software program, but software product is being used by many users of different categories. So just see, for a program, the user interface may not be very important because there is only a programmer who is the sole user. On the other hand, for a software product which has to be used by many users, multiple users of multiple categories, so user interface must be carefully designed and implemented because dwellers of that product and users of the product are totally different. So user interface is one of the important points that has to be considered while we are making a software product. In case of program, very little documentation is expected, but in case of software, the whole documentation is required. A program is developed according to the individual style of development, but the software product, which itself engulfs many software programs. A product engulfs many software programs, means a containership. A product is a container of many programs. So therefore, a product must be developed using the accepted software engineering principles, and it has to be used by the different types of users, different types of developers. So their standardization has to be adopted. So this is the basic difference, and I will also show you that this difference in a tabular manner in a next slide. So just what is the difference? The program usually is small in size, but the product is large in size. The program is authored himself by the sole user, but to programming of the software product, the development of the software product is done by large number of users. Single developer is there, team of developer is there, likes proper user interface in a program, but the software product needs the well-designed interface. Documentation, very small documentation is needed in a program, but the very well documented and user manual is prepared for the software product. Here the development is in program, it is ad hoc development, but here the development is the systematic development. So here we complete the first part of the today's lecture. Now I will move to the second part of the lecture, that is the SDLC. So coming to the second part of today's lecture, that is the software development life cycle. In short, it is known as SDLC. So what is the objective of this topic is, after going through this SDLC part, you will gain an understanding of development cycle of the software. SDLC basically the software development life cycle. What are the various phases which are involved in a life of the software development, and the need for each phase in a development. And after that, you will be able to develop your own software by understanding the various SDLC approaches. So what is SDLC? That is software development life cycle. So it is a framework that describes the activities performed at each stage of the software development project. What happens? The software is developed as a product. So that product, the whole task is considered as a one project. So that is the software project is there. The project is about the developing the software product. So it is not a single step activity. This is the group of different activities which is carried throughout the development cycle, and it is basically a framework which describes all the activities that are taken into account and implemented so that your software product is developed. All the stages, all the phases, all the processes include in this software development life cycle. So what are the different phases? It starts from the first phase, requirement gathering and analysis design. So first is requirement gathering. First phase is basically the gathering of the requirements. That what are the different requirements to develop a software? What are the functional requirements and what are the non-functional requirements of the software? So first step is we gather the whole requirements. After gathering the whole requirements that are needed by the software product, then design analysis is carried out. We make a blueprint of the whole software that has to be developed. So it is the very, very important phase, that is the design, and it is done by the super expert people. They are involved in a designing phase, very important phase. So we will be having a chapters on each and every phase. The first phase is requirement. We will have one topic SRS where we will look upon what are the different types of requirement and how one document has to be prepared for that particular requirement, which is known as SRS document. Then similarly, the second phase is the design phase where the blueprint gets ready. So design, we will again have one chapter on the design. We will discuss is where the different approaches of the design will be discussed in detail. And then we develop. In development, different reviews are taken up out about the software, different small processes and similar operations, and even the coding is done in a development phase and the implementation is done afterwards. So after the software is developed, before launching into the market, testing is done. If still there are certain bugs, some errors, some fault, so that is done in a testing. We have one chapter on the testing where different levels of testing, different approaches of testing, different categories of testing will be discussed in detail. Then the software is implemented and it is launched in a market where it goes to the user, and not here only it does not end. After time to time, maintenance is required for the software at the user end itself, even after the delivery. So what are the different types of maintenance? Why the maintenance is needed? That will be discussed in another chapter, which is related to this phase of the SDLC. So first is requirement gathering, second is design analysis or analysis and design, third is development, then testing, implementation and maintenance. So I will show the another slide where it will be discussed in detail. Next. So I will stop here and just see what are the different phases. Phase one is the just the before gathering. Sometimes we have one small phase, that is the formation phase, where the rough order of magnitude ROM is given. Means what is the basic thing about this software what is the basic need of, what is the vision, what is the policy, what is the thinking about which is behind the development of the this software product, that is lined out in this case. Then comes important, that is the requirement definition. So it is includes, this phase includes the charter, the whole project management charter plan is there. It deals with what are the different types of requirement, either the functional requirement or either the non-functional requirements. We will do this whole phase in very depth in the next chapter. So we deal with the technical requirement. Then we review the whether the requirements are feasible or not. Feasibility is also checked. And then finally it is approved. And then the statement of work is generated. So once this phase is over, then we move to the design phase. So where we have to design the internal as well as the external architecture. The whole blueprint is prepared. Then the review of the design is done. And then the detailed project development starts. Then we construct the prototype of the software. And it is given to the friendly users to get the reviews. And the code review is done. After that, testing is done, where with the different types of testing are implemented. It can be unit testing, integration testing, system testing, different approaches of testing is done, like white box testing, black box testing. So whole testing is done to find out whether there is your software is fault free, your software is bug free, your software is error free. So that has to be considered in a testing phase. Then the next phase is the release of the product, launching the product in the market. After that, once it is there, implementation is done, and finally the maintenance is carried out. So this is the whole different phases of the SDLC, that is the software development life cycle. There are different types of SDLC models which are suggested by the different software development experts, universities, and the standard organizations. So there is not a single SDLC model. Many models have been developed which tells about the different phases of the software. So to help understand and implement the phases of the SDLC, various models have been created by the software experts, universities, and the standard organization. And there is not a single model, because software are categorized into the different categories. So for some category, some model is suited. There are different types of situations before starting the software. There are sometimes different situations where the requirements are not fully frozen right in the beginning. So different model is required, and each model have a different paradigm. But the overall phases, all the phases that I have discussed, those are carried out in each and every model of the software. Why the reason for using the SDLC model? What is the need of generating the SDLC model? Because if if we prepare the SDLC models, they will help us, they will provide us with the basic things which are required. They provide basis for planning, estimation, and schedule. Estimation of cost, estimating how much effort will be required, estimation how much manpower will be required. So SDLC model suggests you different estimating techniques. It will help you the software project management and planning. in which the proper scheduling is done, proper work down structure is done, where we can see whether your product is your development phase is lagging behind the time or it is on the time. So this all things is provided by the models. They provide the framework for standard set of terminologies, activities and the deliverables. They provide mechanism for project tracking that I was telling you, whether your project is in time or not. It is lagging. If it is lagging, how to control? If it is you are lagging behind the development of your project, then how to control, how to cover the time that has been wasted. So it increases the visibility of the project progress to all the stakeholders of the software product. There are different stakeholders. Developers are there, owners are there, testing mind are there, designing phase developers are there, users are there. So they all are the stakeholders of your project. Next. Advantages of choosing an appropriate SDLC. So many SDLC models are present, but we have to see which model will suit to your software product that you want to develop. So it is the expertise now. Here comes the role of the expertise who sees through the requirements and what is the basic output you need from your developed software product. So that on the basis of that, what are the timelines required, how frequent the software is going to change. So these all are the factors are considered in selecting the one of the model from the available SDLC model. So if you select the proper, then the advantage will be speed of development will be high, product quality will be very good. You can uh, improved way of tracking and controlling the development of your software project. You will have a good relation with the clients. Risk, project risk are decreased and overheads which are required for the management of the project, they also get decreased. So these are the advantages of choosing the appropriate SDLC model. Common life cycle models which are in a common are, one is the waterfall model. We will do the two waterfall models. One is the classical and second is the iterative. Today we will cover the classical waterfall model. Second is the prototype model, which is also known as throwaway model. Then is the incremental model, which is also known as evolutionary model. Then comes the special model, which is the spiral model or the iterative model, and it is the meta model. Then the agile model. So we will discuss all these models one by one, but today we will cover the classical waterfall model. So this is the phases of the classical waterfall model. So first phase is analysis, means here the analysis means requirement analysis, feasibility study and the requirement analysis. Then comes the design phase that I have already discussed. Then the development phase, testing phase, deployment phase and the maintenance phase. One important thing about this waterfall model is there is no feedback between the different phases. One, we means all the phases are covered one by one. When you complete the first phase, then only you move to the second phase. You cannot revert back to the first phase once you enter the second phase and so on. So this is the main thing which is in this waterfall model, and this is actually becomes the limitation of the waterfall model, that there is the no feedback available. You cannot revert back. This is the main limitation of the waterfall model. So this waterfall model is the
oldest but the most well-known SDLC model. It follows a sequential step-by-step process as we have seen in a previous slide, from requirement analysis to the maintenance. Systems that have well-defined and understood requirements. Only those systems are found suited to adopt to this waterfall model. Means waterfall model is fit for the those systems, for the those products that have well defined, that is very well defined, means whose requirements are well defined and very well understood requirements. Once the requirements are gathered, we feel that no more requirements are needed. No more changes are needed. So requirements are frozen. That analysis phase of requirement is frozen. Then we move to the design phase. So it is suited for that types of systems. Waterfall model, why it is chosen? It is very easy to understand and very easy to use. It provides a structure to the inexperienced staff also. It is a structured model. Milestones are well understood for each phase. It sets requirement stability, means requirement does not changes. Requirements are frozen. It is good for controlling, management, overall project tracking, and it works well when quality is more important than cost or schedule. Waterfall model, some more characteristics. All requirements must be fully specified upfront. Before the design phase starts, whatever the requirements, they should be very well defined and they should be logged, very well understood. Then move to the next. Deliverables created for each phase are considered frozen. It inhibits flexibility, means there is no flexibility. Once whatever has been done in this phase, you move to the next, you cannot revert back. Can give false impression of progress also. So there are some features which are means these are basically the constraints of the waterfall model. It does not reflect problem solving nature of the software development. There are iterations of phases. You know, so one phase is over, you move to the next phase. Integration is one big bang at the end and little opportunity for the customer to preview the system until it is delivered. So when to use the waterfall model? When requirements are very well known. Only on those systems where the requirements are known in advance. When the product definition is stable, it is not dynamic, it is not changing by the time. When the technology is understood, when new version of an existing product is needed, then we apply also. Already a version is developed, you need a new. So porting an existing product to a new platform, then we use waterfall model. So this is the second portion that we have covered. Now I will discuss the next portion for today, that is the agile software development. Agile software development. Now I'm going to discuss this portion. So this is the last portion of today's presentation, that is the agile software development. So before moving to other waterfall models, other models. I have only discussed the classical waterfall models. While moving to the different models, the first thing is we should have an understanding of the agile model. What is the agile? Because this is the today's requirement. This agility is required today, because I have told you that nowadays what is the situation, that is the dynamic nature of the softwares. So that is carried by the agile models. So after going through this unit, you should be able to understand agile software development, solve problem experienced by agile teams today and tomorrow, and you will be able to speak confidently and eloquently about the agile and provide solutions for the problem that exist within agile teams. Next. So what is agile software development? Agile means which is not fixed. Keep on changing. Keep on changing. Agility is there. So what happens? I've already told you that nowadays the need and the competition in a market is so that a software product has to be, you can say, needs changes again and again, and it is not a set time that after this particular period of time I will just review the software. The requirement for the change can come anytime. It can come anytime, and that has to be incorporated very fast. That is the today's need. And here, to fulfill this need, the type of development which is required is known as the agile software development. So it refers to a group of software development methodologies. It does not consist of a single methodology. In agile software development also, there are many methodologies that are based on similar principles. These methodologies generally promote what they promote. Just see upon a project management process that encourages frequent inspection and adaptation. Very frequently, you review your products, you inspect your product which is in the market, and you see whether it is lacking somewhere, some feature is missing, or if actually the feature was not missing earlier, but now due to competition, any other product, similar product have given some new feature, or by the time some changes are there and user needs changes in your software so that to cover the other changes which are there in a market, that is the adaptability. So in that situation, this type of development helps upon. A leadership philosophy, it is only uh, used by those people whose leader has the philosophy that encourages the teamwork, self-organization, and the accountability. Accountability is the main factor. Everyone is accountable who are engaged in development of the software product. A set of engineering best practices that allow for rapid delivery of high quality software. Means as the change is there, requirement of change is there, you incorporate that change and very soon you deliver that quality software in a market. So this is very much important. The delivery speed should be very high, rapid delivery, and a business approach that aligns development with the customer needs and the company goals. Means you will have continuous alignment between the goals of your company and the what are the needs of the customers. Continuous surveys are done, inspections are done, reviews are done, so that feedback is taken, so that you can come to know if your product is lacking somewhere. And if it is lacking somewhere or some need is required, you immediately incorporate those needs into your software. That type of development or the model is known as agile software development. So some of the principles behind Agile Manifesto are very, the foremost thing is satisfaction of the customer. So how the customer is satisfied? If whatever the requirement customer wants, it is incorporated very fast and the product after the changes are delivered to the customer very fast. So it customer satisfaction by rapid continuous delivery of the useful software. Working software is developed very frequently, rather in weeks and not in weeks and months, very frequently even in days also. Working software is the principal measure of progress. We measure the progress. Even late changes in the requirements are welcome. In the requirement phase, even design phase have started. implementation testing is being done, till some requirement comes, change in requirement comes, that will also be incorporated. Means feedback is there. Close daily cooperation between the business people and the developers. The your marketing people of the company keep on taking the feedback from the market about the product, and they pass on those changes which are required, those feedback to the developers, and they see what changes are required and how rapidly those changes are to be incorporated. Face-to-face conversation is the best form of communication when we develop the take on to the agile software development. So all should be the co-location. The team should not be separated. Projects are built around the motivated individuals who should be trusted. Continuous attention to the technical excellence and good design. This is the major thing. Continuous attention is given to the excellence, that you want that your product should be the excellent, technically very fulfilled, and it should have very good design. And but those simple, very simple to use. The team structure is self-organizing teams are there, and regular adaptation to the changing circumstances are incorporated. So this is the major thing. So just see the overall picture of the agile software development. So there is a project backlog, iteration blocking. So increment is iteration very fast is there. Daily synchronization is done with your people in the market and your develops, and they keep on changing, and they increment the product and make the new releases of your product very frequently. So introduction to the different types of agile methodologies. There are different methodologies. One by one I will cover. First is the most popular one is Scrum. So it is an iterative process again and again, which is in loop. It is an iterative process of development used with agile software development, where the changes are incorporated in iterations. The roles in a Scrum are Scrum Master. Means what are the different roles to the different people which are involved in a team? So those are Scrum Master, the product owner, and the team. During each sprint, means each iteration or in each pass, the team creates an increment of potential shippable software. The set of features that go into each sprint come from the product backlog. Means what more features are required. So those features are collected at the backend, and they are kept as a backlog. While backlog, which backlog items to go into the sprint is determined during the sprint planning meeting. The team then determines how much of this they can commit to complete during the next sprint, and during the sprint, no one is able to change the sprint backlog. So these are the features of this methodology, which is known as the Scrum, and it is the most popular. Now look onto the another methodologies also. So next methodology is extreme programming, and it is also known as third methodology. It is a traditional software engineering practices where the daily interactions is there with the team and the market people and the developers working. Software testing is done, means the members involved in all the phases of the development of the software, they have daily interactions. So they are taken to so-called extreme levels. Frequent interaction is there, daily interaction is there. So it is in a extreme level. It leads to a process that is more responsive to the customer needs while creating the software of better quality. Next methodology is Scrum XP second. So it is a feature driven development. So it is really used, but more features are added. So it is a feature driven. It depends upon a new feature that has to be added. And in every iteration, a new feature is added into your software product. This practice is driven from a client valued functionality perspective. Means Valued functionality means a client wants the new feature. So then you move to this methodology. Test-driven development, a software development technique that uses short development iterations based on pre-written test cases that define desired improvements from a new function. So improvements are needed after the testing is done. So each iteration produces code necessary to pass that iteration test. So testing is done, your product is made error-free, fault-free again and again. And last is the lean. It is a process designed to eliminate waste, amplifying the learning, making the decisions late, even late decisions are made, and that decisions are also incorporated. Fast delivery is the main requirement. Empower teams because you have to deliver the final product on a very, you can say, if the decision is made very late, then also. So team is very much empowered, product integrity is there, and fully understood system is there. So the people involved in agile methodology are, first are the agile team, which includes architects, developers, analysts, designers, then the quality assurance testers, tech writers. So this is the first agile team. Second, people involved are product owners, which are also known as, and the customer representatives of the customer, which give the suggestion or requirement that this change has to be there. And the owner of your product is there, which is known as the customer who own the project, who purchase your project. And the project managers are also known as the Scrum Master if the Scrum methodology is used. So they deal with the whole development of the Agile methodology. So teams are here small, preferably 5 to 7, preferably co-located in a same location so that frequent meetings can be done cross-functional. So scale by teams, not more people. So more teams can be added, but in a single team, number of people remain mostly less. The other people involved in this methodology are product marketing communications, directors, executives, but their role is different. They can attend the daily meetings but cannot speak. They can participate in planning works. They interact with the team through project manager only. They speak very less. They do not speak. They just attend the meeting and they want to say something. That is their communication to the other members is gone through the project manager. So last is, what is difference between a project? I have used the two terms product manager and the product owner. So what is basic difference in these two terms? So one is the product owner who owns the message to the agile team and the sprint iteration back. On the other hand, product manager owns the roadmap, strategy, vision, product bylaws. So that is the main where the main development process is being carried out. So one is the product owner and second is the product manager. Often they are same person sometimes and the problems with this site are well documented. So not only one note should there, only Scrum calls the product owners. Other flavors reference customer representative. So name given that the product owner name is given basically in a Scrum methodology. So other methodology give the name as customer representative, visionary, business domain experts. So this the resource of this presentation is from the Scaling Software Agility blog by Dean Lassenberg. So this is all about the agile software model. So I hope you understood well. It is thanks.